Okay, so another way of doing a partition. Okay, we're just going to partition X. Now we could just partition Y if we wanted to come out very similar. But we're just going to partition X. So in a typical xi minus 1 to xi, typical thin strip of this rectangle, we choose a sample point between xi minus 1 and xi, just pick it randomly, or pick it by some algorithm, it wouldn't matter, okay? Pick it by some non-random algorithm, contrast with a random choice. Anyhow, in 3 dimensions, we'd have our xi star here. Here's our rectangle. And we have a function f of xy up here somewhere. I'm not going to attempt to draw that graph, but we know that if we then slice the graph of f of xy with the plane x equals xi star, we're going to get between our y limits, in other words, above this rectangle, we're going to get something that looks like this. Okay, whatever the function looks like. Okay, so we can say, okay, well, these aren't partition lines, just projection lines to show that we've sliced our function f of xy along the plane x equals xi star, plane parallel to the yz plane. Okay, the function is a graph of f of xi star y. In other words, you replace x by whatever number xi star is, and you get a graph of simply, this is one variable. Got one variable, which is y. So, what's the area underneath the graph? You just integrate with respect to the variable y. Obviously, y is what's varying here, right? Okay. Now let's put a couple of numbers. Let's say, again, here we go from A to B, and from C to D. Now, of course, you've got your xi plus, or your xi and your xi minus 1. I'll kind of exaggerate how far apart these are. They're not going to be very close together, but so here's xi, here's xi minus 1. Well, if we do the same thing at xi, we're going to get a graph. If we do the same thing at xi, if we slice the graph of f of xy with the plane x equals xi, it's going to look a whole lot like this, but maybe a little different. Okay? If we slice over here with at x equal xi minus 1, it's going to again look sort of similar, but maybe not exactly the same. Okay? And now if we connect everything, we've got a three-dimensional region here, okay, between the xi slice and the xi minus 1 slice. If the base is this face of this three-dimensional region, then the altitude is what? And well, okay, we've got this region. We're going to take the base to be the front face. So that would be this. What's the altitude? Well, now here's where the deficiency in our teaching of geometry might cause us a little bit of a problem, because the definition of an altitude is, don't want to give it too precise of a definition, it'll be confusing. It's a dimension perpendicular to the base. Okay? So altitude is measured perpendicular to the base. So what's the altitude? Can you write it down? Got the camera going, so we don't want to do too much. Don't want to use. Okay, well, the altitude goes in which direction? Can you point to the direction? Yeah, that direction, right? Or that direction, because it's the same direction. Okay, so along that line. And that line is parallel to one of the axes, isn't it? Which axis? That's what I was waiting for, but I know you know because of your gesture. Okay? Very good. Very good. And hopefully nobody could see your shadow so they could identify you, so their privacy clause and stuff. Yeah, and unfortunately we got to live with it. And I mean, there's a good reason for it, but it's a pain. Okay. And sometimes you have to have trade-offs. Okay, well, anyhow. Okay, so the altitude is measured perpendicular to the base, so now we could write down what the altitude is. How far is it from this face to the back face, because that's where the altitude is? Well, it's just the difference between this coordinate and this coordinate. Okay? So we could abbreviate that. We could define that to be delta x sub I. Okay? That doesn't mean the change in x sub I, that means a delta x for the ith interval. Okay, well now what's the volume? Okay, well the volume is the area of the base times the altitude. Now, you're going to want to think of this rectangle down here as the base, but that's not it. The face here is now the base. And the area of the base is what? Is it up here on the board somewhere? Can you point to it? Yeah, it's right here, isn't it? Okay? I think that's where you're pointing. It looked like. Okay? You gotta learn sign language. That's how we communicate. I don't think it would stick in my feeble head. Einstein said something to the effect that English just will not stick in my old head. He was in his 40s. And so, you know, just a little older than I am. Anyhow, there we kind of have the picture. Go ahead and make this even clearer. Oh, that's good. Okay, so now I say volume equals, volume's approximately equal to the area of the base times the altitude. Okay? And I guess there's one other step. Okay, the area for the cross section at xi, which is the base, right? So I guess that's not going to be too far from the area of the cross section at xi star. Therefore, the volume that I'm not going to designate delta V sub I. Okay, it's the incremental contribution of the volume corresponding to this strip to the whole volume of this of the region of three-dimensional space above this rectangle and below the graph of f(xy). So therefore, the volume delta V sub I is approximately equal to well, what's the area for the cross-section at X sub I? There it is, right? The integral of f of x I star y dy. And the integral would be from what to what? I put symbols for the y value here and the y value here. So the integral would be from C to D. Okay? So it's the integral of this from C to D times delta x sub I. Total volume, that is sum from I equals 1 to n of delta V sub I. And that, I'm not going to develop totally, although I kind of want to, and I could, but for time consideration, I'll leave it to you. It's this. In other words, we sum up all these, and that amounts to integrating this with respect to x. In other words, when we integrate with respect to x, we're just summing all these, the volumes of all these strips. Okay? So now we want to look at how you do this kind of an integral, and it's really straightforward. Okay? So we're going to look at that.